a manufacturer of precision machines in Tokyo. The company only employs about 100 people, but their machines are used to draw lines in the nanometer scale. What exactly do they look like? We got a special demonstration from Kodama Satoshi, who works in engineering. First, a round silicon wafer, a material used for semiconductors, is prepared about 15 centimeters in diameter.
微細なパターンを描画していきます。
The wafer is loaded in. Next, the desired pattern is entered on the computer. Click Start, and voila! This is the result. If you zoom into the center of one of these patterns with an electron microscope, you can see lines which are invisible to the naked eye. If you zoom in even further, here, lines that are 15 nanometers wide. 15 nanometers is over 5,000 times thinner than a human hair.
How small can you get? We've been trying to push the limits. It's an incredibly difficult technical challenge, but I think it's really rewarding to be going after something like that.
Just how are these lines being drawn? The key component is here. This cylinder, known as the optical column. A special beam is formed in here and used to draw the patterns onto the silicon wafer. Electrons, one of the subatomic particles found in atoms. A beam of these electrons passes through a series of lenses to focus it. The focused beam is used to draw the lines of the pattern. Many different patterns can be entered into the computer and drawn with the machine. Electron beam lithography. Its main use is for electronics to make their semiconductor chips. Extremely fine circuits can be drawn with these machines. They're contributing to improving the performance of semiconductor chips.
As the number of circuits increases, so does the processing speed. The smaller the elements are, the better. So we're developing ways to make things even smaller and pack in more circuits.
The company is dedicated to making finer lines. This drive has been part of the company since it was founded in 1975. The engineering group applied electron microscope technology to develop the electron beam lithography systems. Their business proved successful as Japan's semiconductor industry matured. After that success, they turned their attention towards the demand in research. Labs at universities were looking for devices which could draw thinner lines than ever before as they researched nanotechnology.
I heard we were occasionally hitting 50 nanometers, while others were only at the 600 range. But researchers wanted 10 nanometers to do new research. Our company was an expert in the field, so it was worthwhile to pursue a goal no one else could reach.
In 1996, after much effort into developing electron guns and lenses, the company succeeded in drawing lines that were 10 nanometers wide, 1/5 of their earlier model. But they didn't stop there. 5 nanometers, and then 4. In 2018, they reached 3 nanometers, the thinnest in the world. Their technical accomplishments have garnered attention around the world, and their devices are being used at famous universities like Harvard. Lately, their work is being used in the research and development of quantum computers, capable of solving complex problems much faster than conventional computers.
When you're at the forefront of nanoscale technology, even something like making a tiny dot is going to be a necessary process when creating components for quantum computers. I'm working with the thought that we're helping to push the field of nanotechnology forwards.